In today's tutorial, we're going to continue our work on the bridge spawner script. Mainly, we're going to generalize our spawn logic to randomly generate and spawn infinite segments in different directions. I must admit, this is perhaps the most difficult tutorial in this course because it's going to involve some coordinate math that you may not be used to doing. So prepare your brain to do a little more work in this tutorial. In any case, I'll try my best as usual to make the concepts in this tutorial as clear and as concise as I can. But you may have to pause and rewind certain sections in this tutorial, that's all. So let's open up the bridge spawner script in Visual Studio and get going. First, let's work on generating the random bridge segments for the different direction cases because we already know how to do that from the previous tutorial. So let's step into the body of the create segments function and uncomment this line because we're now ready to deal with the corner segments. Let's just add another case for the east direction. And now we'll randomly choose between a left corner or a straight segment for our segment type, which our enumerator has numbered as 0 and 1 respectively. Now if our segment type happens to be straight, then much like in the north direction, we'll be randomly choosing a straight segment from our bridge prefabs array and assigning it to the seg prefab member of our segment object so that it can be later spawned in the scene from the spawn segments function. Else if the segment type is a left corner, then we want to assign the left corner bridge prefab to the seg prefab member of the segment object, which is stored in the 7th element of our bridge prefabs array. And finally, we'll repeat the same process for the west direction, only this time we'll be choosing between a straight and a right corner segment, which are numbered as 1 and 2 respectively in the n-type enumerator. And of course, if a right corner bridge segment is randomly generated, then we'll assign the right corner bridge prefab stored in the 6th element of our bridge prefabs array to the seg type member. And we went over why it is that we can't spawn a left corner segment if the current spawning direction is west, or why we can't spawn a right corner segment in the east direction. So if you somehow missed that part, then go back to the second player logic tutorial where this is explained in great detail. Okay, now comes the real challenge of this tutorial, which is figuring out the correct spawn coordinates in the scene for the segments once they have been randomly generated. Ideally, we would like some sort of a general formula that's gonna help us place the segments correctly in every direction. And we already have a formula for the north direction, which is to add a segment length amounting to 6 units to our spawn coord variable every time the player crosses 2 segments. However, when it comes to the east and west directions, it becomes a little tricky because we have to consider both the positive and negative x directions, in addition to the z direction values. So how do we go about finding the magic formula? Well, I know only one way to do it, which is to manually place different segment types in the scene and hope we can find a pattern that we could then turn into code here in this script. So let's go to the editor and see how that works. First, let's have a zoomed out game view to properly test the game. Let's turn our camera 90 degrees around the x-axis so that we could have a 2D top view of our game. Also, let's elevate the camera by 30 units and bring it forward by 25 units. And let's drag it to the right by 25 units. And here is our player. Now let's go to the prefabs folder in the project assets folder. And let's start by dragging a regular iBridge onto the scene. As you probably know, this segment game object is facing north with spawn coordinates 0, 0, 0 and no rotation. So we're not saying anything new here. Now suppose the create segments function from the bridge spawner script has randomly generated a right corner segment. Then where should the spawn segments function place it in the scene? Well, it should place it at 006 with 0 rotation because the iBridge segment prefab has a length of 6 units and hence there is just a 6 unit increment in the z direction to the spawn coord variable from the previous position. So that's easy. However, now the spawning direction for the segments has become east, so this is a new piece of information for us. So let's go to our bridge spawner script and program this bit. First, let's store the segment length in a float called segLength, and also store the segment width in another float called segWidth. This is so that we know what it is that we're adding to the spawn coord variable as opposed to adding 3s and 6s, which is much easier. Okay, let's go inside the switch statement of the spawn segments function and add a new else-if line to the north direction case. Else if the segment to be spawned is a right corner segment, then as we said it should have no rotation because it's in the north direction. And now the segment next direction is east. Also, since the previous spawn segment is a straight segment, this means that the spawn coord for this segment needs to be incremented by that segment length in the z direction. But that's not all, right? Because before we start spawning new segments in the east direction, we need to account for the right corner segment's contribution to both the z and x components of the spawn coord variable. So we need to figure that out in the editor. Now suppose that an I-bridge segment is randomly generated right after the right corner segment. Then how much change should there be in the spawn coord variable for us to be able to correctly place this I-bridge segment in the scene? Well, let's place this I-bridge segment exactly where the right corner segment is placed in the scene, which is 006, and it's the one highlighted in green. Now let's calculate how much the right corner segment changes the spawn coordinate for the new segment, which is the I-bridge segment. Ahead, there is just an increment of 6 units, so let's add it to the current spawn coordinates, which gives us 12. And then there is half a length of a corner, which is 1.5 unit. So this makes the z value 13.5. This means that every time a right corner segment is spawned in the scene, there is a segment length plus a segment width over 2 offset in the z direction for the spawn coordinates. Now let's rotate the I-bridge prefab by plus 90 degrees around the y-axis so that it can face the east direction. And for the x component of the spawn coordinates, there is just an offset of half a width of a corner, which is just a seg width over 2, and that's equal to 1.5 units. Now our spawn coordinates have been offsetted correctly to account for the right corner segment. From now on, we can just keep adding straight segments with seg length increments in the east direction because we have done the right corner offset correctly. So this should be 7.5 now. And if another straight segment is randomly generated, so let's duplicate the segment, it should be spawned a seg length more than the previous segment in the east direction. So this should be 13.5 and so on. Now let's go to our bridge spawner script and code this bit. First, we need to add a local vector3 variable to our spawn segments function called offset and initialize it to 000. This means that the values in this vector3 are gonna get reset to 000 every time the spawn segments function is called so that they don't accumulate. Also, these are called local variables because they are locally defined here in this function only. For example, if I go to the remove segments function and try to access the value for the spawn coord vector3 from the spawn segments function, Visual Studio will give us an error because the spawn coord variable has no definition here in the remove segments function. It has a definition in the spawn segments function only, and we may want to do that for a variety of reasons. For one, we may want to protect the variable from getting adjusted from outside the function scope, so we write it to be specific for this function and this function only. Another reason is code optimization. These local variables are automatically loaded into the computer or phone's memory when the function in which they are defined is called. Then they get automatically destroyed once the code in the function is done executed. Hence, they are also called automatic variables. However, the variable declared within the main class of the script here up top are called global variables, meaning they are defined everywhere in the script. I figured you should know the difference between local and global variables at this point in the course. Okay, now let's go to the else if line for when a right corner segment is spawned in the north direction and add the offset values. We said that a right corner segment adds a segment length plus a segment width over 2 in the z direction of the spawn coordinates. We also said that a right corner segment offsets the spawn coordinates in the z direction by a segment width over 2. Now once a right corner segment has the correct spawn coordinates and then instantiated in the scene, add its offset contribution to the spawn coordinates of the future segment and then reset the offset variable, so that if a straight segment is spawned, it doesn't offset anything in the spawn coordinates, which are controlled by the spawn coord variable. I think you are well aware of this fact, I just wanted to reiterate it for clarity. And let's also account for the left corner when the spawning direction is north. The code is very similar, only this time the segment next direction is gonna be west, and its offset in the x component is subtracted and not added because the west direction values are negative. Now we're ready to extend our spawn segments logic to the east direction. So let's add another case to the switch statement and call it east. And if the randomly generated segment that is stored in the seg-type member of our segment object is straight, then it should have a rotation of plus 90 degrees around the y-axis with no change to the previous segment spawn direction. So the seg next direction should be east. And the spawn coordinates for a straight segment in the east direction will be a seg length increment in the x direction from the previous spawn coordinates with no offset because it's a straight segment. And for the left corner, else if the segment direction is east and a left corner segment is randomly generated and ready to be spawned here from inside this function, then it should be rotated by plus 90 degrees around the y-axis just like the straight segment case. But now the segment spawn direction should revert back to north and should be spawned a seg length more than the previous spawn coordinates in the x direction. However, now we need to offset the next segment spawn coordinates in the z and x directions just like we did in the north direction case. And the offset values are very similar to the right corner north direction case, except this time we'll switch the x and z components because we're running on the positive x-axis. Finally, we'll copy this block of code for this direction and mirror it to the west direction case. and this here should be a right corner segment. And we'll adjust the rotations to be minus 90 degrees around the y-axis for the prefabs. And in the case of a straight segment, keep the segment spawn direction west. Lastly, we need to subtract from the x component in the spawn coord variable to account for the west direction's negative values, and also here, and finally here. Also, this should be replaced with the seglength float. I don't know why we haven't done that earlier. Now, believe it or not, we have completed coding the infinite spawn logic in our game. Our game can now literally spawn infinitely many bridge segments in all directions and in a random manner that ensures that the game is not repetitive or boring. And we were able to implement such a complex logic system by cascading a bunch of switch and if statements. I recall seeing one time the source code of a similar game that used a really elaborate recursive function that was just way too complicated. This is one of the many perks of taking this course, which is that we take a logical and simple approach to game development. Game development doesn't need to be hard, it just needs to be logical. Now let's save the changes to the script and give our game a go in the editor. Let's quickly delete all the bridge segments from the game object hierarchy now that they have served their purpose. There is now one little temporary adjustment that I need to make in order to test the infinite spawning logic of our game, which is replacing all the obstacle segments prefabs with regular iBridge segment prefabs in the bridge prefabs array from the bridge manager game object. This is because our player still cannot jump or slide, so he'll get stuck if he faces an obstacle segment. Once we're done testing our game, we'll undo these changes. Let's hit play and see our game in action. As usual, the first 5 segments are regular iBridge segments, and now the player encounters a random right corner segment, and then immediately a left corner bridge segment. So it seems like we are correctly spawning different segment types in the scene in all different directions. There is just one thing I don't like, which is that we are destroying the previous segments a little too quickly. So let's go back to the bridge spawner script and increase the spawning trigger distance here in the player trigger function. Let's make it 16 units. And now we need to make sure that this distance float is a positive number so that this condition can be met. Because now our player could be running west, which is defined with negative values in the Unity coordinate system. So let's put the whole float inside an absolute value function, which is under the mathf class in Unity. So type mathf dot abc big A, open a pair of parentheses, and paste the distance inside the absolute value. If we don't do this, then we must add another else if condition that checks for when the distance is negative. But this absolute value takes care of the negative values by turning them into positive values in a single line. Now let's save the changes in our script and give our game another run in the editor. Okay, this looks better. But you know what? 16 may be too slow. Let's try 15 and see what happens. Okay, so this seems good. Again, if you feel like you need to adjust the spawn trigger distance value to suit your liking, then you should do that. You don't have to follow every tutorial in this series to the letter. In fact, I encourage you to experiment with adjusting different parts and values in the code, so that you could really see what their effects are in the game. Before we officially call it a day, let's put the bridge obstacle prefabs back in the bridge prefabs array in the bridge manager game object. And with that comes the end of this tutorial. This may not have been the lengthiest tutorial, but it probably was the trickiest to do in this series. I would strongly encourage you to go over the code once more and try to really grasp how the logic was implemented. And if you have any further questions regarding this tutorial or any other tutorial in this series, then please shoot them to me here in Udemy. I'll be sure to answer all of your questions in great detail. In the next tutorial, we'll animate our player and also code his jump behavior so that he could get past the obstacle. Thank you.